Okay, now we want to look at the laws of indices. Remember I said if you're to solve any question in indices, you have to know the laws of indices in its variety. Now there are several laws of indices, and for this lesson we'll just be looking at the first four. Then in my next lesson I'll be showing you the further laws of indices. Now let's go. Now the very first law of indices is the multiplication law. The multiplication law. And the multiplication law states that if two or more terms have the same base and are to be multiplied together, their indices are added. So if two or more terms have the same base and are to be multiplied together, then their indices are added. Now you can see the formula here. This is two terms, and as you can see the two terms have the same base xx, and this a and b are their indices. Now it says that when you are asked to multiply two terms that are similar, then what do? You simply add their indices. So you can see here x raised to the power a times x raised to the power a is equal to xa plus b. So now you can see some examples that we have on the board here which we are going to solve. Now the first one is 10 raised to the power 5 times 10 raised to the power 4. So we are going to follow this example here, which will be 10. Since these two bases are the same, we can just go ahead and add their indices. We have 10 here, we have 10 here. So we're going to add their indices, which will give us 5 plus 4. So when you add their indices, you're going to get 10 whole number raised to the power 9. Very, very simple. The multiplication law states that when you have two or more terms that have the similar base and you're asked to multiply them, all you have to do is what? Add their indices. So that's what we did here. We just added this index of 5 to this index of 4, and then we got a 9. So let's look at the second example, which is 5y times 4y raised to the power 4. Now as you can see here, we have a 5y and we have here 4y raised to the power 4. Now you can see that the only similar terms here are these two y's. So in this case, you're going to have to multiply these two other terms, 5 and 4, separately, and then you now apply the law of indices to this y, because this y and this y, they are what? They are similar base terms. So when you come here, you now say 5 times 4, you multiply them normally because they are not similar. Then you now put in brackets, you put your y, and then you now add their indices. Now this y here, this index, the index of that y here is actually 1. You know, when you raise any term to 1, it gives you that term. So it doesn't really affect this value, but let's just note that the index of this y here is 1. So we will know that the index of this one will be 4. So we'll now add 4 here. So here, 5 times 4 will give you 20, while y will be raised to 1 plus 4, which is 5. So when you are multiplying similar base terms, please note that by the law of multiplication, you have to add their indices together. And in this case here, this 5 and 4, they're not similar. That's why we multiply them normally. But this y and y, they are similar. So we now apply the law of indices, in this case the multiplication law, to this y and to this y raised to the power 4. Note that this y is raised to the power 1. That's where we got this one from. So y raised to the power 1 is still y. It doesn't really affect the value. So we took the 1 from here and added to the 4 here. At the end of the day, the answer here is 20y raised to the power 5. Now let's go to the second law, which is called the division law. And the division law is kind of like the inverse of the multiplication law. And the division law states that if two or more terms have the same base and are to be divided, their indices are subtracted. Now you can see here that once again the base is here are similar, which is x and x, and each of them have their own what index. Now this has an index of a, this one has an index of what b. Now it says that when you have two or more terms that have similar bases and you ask to divide these terms, what do? You subtract their indices. Now I just want us to note that this expression here can also look like this. It looks like a fraction here, but this is the same thing as this. So sometimes you might see something like this, sometimes you can see something like this, but at the end of the day, this is what you use to what? Solve them. So whether it is this or this formula or this expression or this expression, this is how you're going to apply it. So now let's look at the example here. And the first example is 22n raised to the power 7 divided by 22n raised to the power 7 divided by 2n raised to the power 3. Now, as you can see, when we talk about indices, we're only dealing with those numbers that are similar in base. Here we have 22 here and we have a 2 here. Then we have an n raised to the power 7 and we have n raised to the power 3. You can see that this n and this n are similar base, but these ones are not similar. So what do? The ones are not similar, you just simplify them normally. So in this case, what you're going to do, you're going to say 22 divided by 2. And then you now take your n. The law says that if you have two similar terms and you ask to what divide them, then what do? You subtract their indices. So in this case, it's going to be 7 minus 3, close the bracket. So now this 22 will be divided by 2 normally, which will give us what? 22 divided by 2 give you 11. Then your n, 7 minus 3 will give you what? 4. So that would be the answer to that. Once again, let's go through that. 22 n raised to the power 7 divided by 2 n raised to the power 3. Now, 22 and 2, they are not similar what? Bases. So what you're going to do, you're going to have to divide them normally, which is what I did here. 22 divided by 2 is 11. Now, for these 2n, which are similar bases, what you do is that you're going to subtract their powers from each other. So you now say n raised to the power 7 minus 3, which will give you n raised to the power 4. When you now combine it together, you now give 11 n raised to the power 4. Now let's look at another question. Another question which is simplify 24x raised to the power 6 all over 8x raised to the power 4. Now you can see this now has the same look as this expression. You can see this is over this, which is what I have here. So it's still following the division law. So what do you do in this case? You identify the term that has the similar base, and you can see that it's x and x. They have similar bases. But 24 and 8, they are not similar. So what do? You divide them normally. And just by looking at them, you can see that 8 will divide itself 1. 8 divide 24, 3. So you will now be left with what? 3x raised to the power 6 all over x raised to the power 4. Now, according to the law of indices, the division law says when you have similar bases and you're asked to divide them, what do? Then you're going to have to subtract their indices from each other. So here you now have 3x raised to the power 6 minus 4, which now give you what? 3x raised to the power 2, which will now give you your final answer. So you can see that by applying these laws of indices to the questions, we're able to now solve the questions of indices. But first of all, you have to identify which of the laws of indices you are going to use to solve the question, and it's by the nature of the question you're being given that you now know which law you'd have to apply to it. So this is the first and second law. Let's go to the third law, and the third law is known as the power of zero law. Now, the power of zero law states that anything raised to the power of 0 is equal to 1. Anything that is raised to a power of 0 is equal to 1. So it doesn't matter what the value of the term is. As long as it's raised to a power of 0, then it is equal to 1. So we have just one example here, which is 19 raised to the power 0, which is 1. Now, the only condition for this is that that base must not be equal to 0. Like you can see here, x must not be equal to 0 for this condition to be true. So anything or any term raised to the power 0 must be equal to 1 as long as the base is not equal to 0.